4.2 is on the mean value theorem. It is a very important theorem that's used to prove a number of other critical things later. It's interesting in and of itself, but mostly used to prove other things throughout math. So, mean value theorem uses what's called Rolle's theorem first to show something. It has to do with max and mins and horizontal tangents, stuff like that. So let's look at the hypothesis first. Let's let f be defined, a function defined on the closed interval from a to b. And then we'll do hypothesis like 1, 2, 3. So first, hypothesis is that f is continuous on AB, kind of important. Like very important, it's continuous. 2, f prime exists on the open interval. So it's differentiable on the open interval, in other words. So f prime exists on the open interval from A to B. And 3, f of A equals f of B. So they're essentially the functions equal at the endpoints. So if that's true, this is the conclusion, then there exists a C in the open interval from A to B such that f prime of C is equal to 0. So that means horizontal tangent, essentially, is what that's saying. So geometrically, we'll look at the proof in another video. I want to just go through the concepts first. So geometrically, this is pretty clear what's going on. It's like a simple thing to show just by looking at the picture. So you have, say, this is A, and this is, just go all the way out here, this is B. And those points, let's just say, are here and, well, actually, I meant to, it doesn't really matter where it is. So there and there. So the function values are equal. So this value right here is the same. So that's your f of A, and this is your f of B. So if you as you're doing the function, you have to get from here, and it's a function, to here. I made a straight line, right? So it has to get there somehow, right? And if it does that, then, so it doesn't matter how you get there. So it can't be broken up like this, right? Because that would not be continuous. So what that's saying, at some point, there has to be a horizontal tangent. So if it does that, there has to be one. Let's do one. Let's just have one horizontal tangent here, the way I draw this. So suppose it does that. Then your C value, of course, would be right here. That's your C. And so that, of course, is horizontal. Okay, and we'll do it just like that. So right there, we know that f prime of C is equal to 0. So the geometric concept is pretty straightforward. It has to be true. It's differentiable everywhere in the interval. And so you get f prime is 0. So that's Rolle's theorem. The mean value theorem, basically what it does is it takes this, let's just copy this thing, and then I'll write it up. So it takes this and basically just turns it like that. Now the axis doesn't turn, of course, but the function does. So basically it turns it like that, and it's essentially saying you have these values that are the same. Draw it like this. You have these values that are the same, and so you have the same slope. So this slope and this slope must exist. That's essentially what the mean value theorem is saying. It's just turning it on its side. And so the slopes are the same. Okay, now I'll redraw the actual one for the mean value theorem. So that's Rolle's theorem. And we'll look at the proof later. It's in the book, and it's not too bad. It just has to go through little steps. I'll just say another different video. Okay, so here's the mean value theorem. And it's the mean value theorem. So this is almost like the fundamental theorem of calculus, because it's where all the work is, and the main reason we can prove what the fundamental theorem of calculus is later in the class. So the mean value theorem. So let F be defined on the closed interval from A to B, and then 1, F is continuous on the closed interval from A to B, and 2, F prime exists on the open interval from A to B. That's your hypothesis. Then, same concept, there exists a C in the open interval from A to B such that, now this is a little different, but this is basically the slope of the secant line is the same as the slope of F prime of some value C, such that F prime of C equals, and this is the secant line, F of B minus F of A all over B minus A. Okay, so let's move that down. All right, so that slope of secant line. So picture of that thing would look something like this. Let's see. I can do it right here. So you have your graph. All right, so then let's say this is A to B. And then you have some function that does whatever, like that. So this is F of A, this is F of B, and then there is a secant line that goes through that, right, just like that. And the slope of that line is just that, right? So this is a F of A, and this point would be B F of B. And so basically there has to be some value. Let me move that. Always happens. Put it right there. There must be some value that gives you that same slope. So I'm going to actually copy, if I can. Oh, there it is. Yeah, copy that. I'm going to paste it. And basically, right there has to be the same slope. Right there. There. So right, say here is your value C. So that's that's the concept. So secant line, the slope is change in y over change in x. So your change in y is f of b minus f of a, and your change in x is b minus a. So it's saying basically there has to be another value c that you go up to the line and you have that exact same slope. Because the graph has to somehow get from one place to the other, and there's going to be those same slopes. Okay, so that's the concept, very important idea. Okay, let's look at an example how we would use this. Well, just like this is just the mechanical example. Oh, and then I wanted to put down proof later. I won't hold you to the proof, but I wanted to go through it in the video if I can. You don't have to worry about it, but I want to show it to you if you have a chance to look at it. Okay, so here's an example. If f of x equals, so I'm giving you an actual function, x cubed minus 8x minus 5, show that f satisfies the hypothesis of the mean value theorem. And this is used so much we have a abbreviation for it. Mean value theorem is I was just doing something in I guess it was Calc 3. It just using Calc 2 and a number of different proofs, but happened to be in Calc 3 where you use it to, it comes in and like deriving the length of a curve theorem formula. Anyway, so just thought of that. The hypothesis mean value theorem on 1,4. So hypothesis is the existence of C, and then it asks you actually to find C in 1,4 that satisfies the conclusion. So that's not the mean value theorem. It just says that it exists. It doesn't say how to find it. So find C in the open interval that satisfies the conclusion. So most of the hypothesis is pretty straightforward. I mean, you're just going to say and restate it. F is continuous. Well, F is a polynomial, therefore it's continuous on the reals. F is a polynomial, so it's differentiable on the reals, so it satisfies those. I mean, that's all you got to say. You just got to state it. Okay, so we'll just state that. Okay, so since F is a polynomial, F is continuous and differentiable on R, and therefore, of course, on those intervals. All right, there's not much else to say there. All right, so then there exists a C in the open interval from 1 to 4 such that f prime of C, I'm messing up my handwriting here, such that f prime of C is equal to and then we got to just find that difference, which is f of 4 minus f of 1 all over 4 minus 1. So all you have to do is calculate that difference, and then so you're going to calculate the difference and then set the function equal to whatever this difference is, and then solve. It's really easy to actually solve it, but that's not really the point of the mean value theorem. This is just kind of an exercise to get you used to it. So let's calculate f of 4. F of 4 is 4 cubed minus 8 times 4 minus 5. And then you can trust me, it's 27, or actually don't calculate it. F of 1 is 1 cubed minus 8 times 1 minus 5. Also calculate, is negative 12. So f prime of x, right, it says the derivative equals that ratio. So f prime is 3x squared minus 8. And so then we have 27 minus negative 12 all over 3, 4 minus 1 is 3, is equal to, and then that's going to be 3 times c squared minus 8. And then we evaluate that. So do the little calculation here and solve. All right, so that gives us 21 is 3c squared. So c squared is equal to 7. So c is equal to plus or minus the square root of 7. And then which one do we use? Well, negative root 7, is not in 1,4 because it's negative. So c has to be the positive square root of 7. So that's my value c. Okay, so that's just how you would calculate it and show that something works. I almost always ask this type of question because I want you to study the mean value theorem. It's a really important theorem that comes around a lot. Okay, I think that's it for that section.